Okay, students, let's see that complex compounds objective from first one. Yes, ma Vivek, will college will be open first January 1st onwards. First day onwards only the colleges will be open. Okay. So you have exam on 4th. Okay, students, these questions all are very easy only, and main concepts we need to remember, theoretical concepts and rules and regulations and important points. Then we can solve these questions very easily. Let's see the first one. The oxidation number we need to find out of central metal ion, cobalt oxidation number. Okay, students, how to find out the cobalt oxidation number? See, on the coordination complex, the total charge is equal to 0. Sum of the all atoms oxidation number is equal to 0. Potassium, let it be cobalt oxidation number plus 4 CO ligands. Carbon monoxide ligands is equal to 0. Then potassium is first A group element, its oxidation number is 1. Cobalt, let it be X. CO is a neutral ligand. Neutral ligand. Oxidation number is equal to 0. That's why 4 into 0 is equal to 0. Now the X is equal to -1. So the answer is the third option. Okay, students. Let's see that. Second question, EDTA -4. EDTA is a hexadentate ligand. So the answer is fourth one. Let's see the structure of EDTA -4. EDTA means ethylene diamine tetraacetate. Ethylene diamine tetraacetate. CH2 COO minus and CH2 COO minus. This is how many donor atoms are present here, students? Nitrogen having lone pairs. So it is 1, 2, and oxide ions 4 are present. Acetate ions 3, 4, 5, 6. So 6 donor atoms are present. Hence, it is a hexadentate ligand. Okay, students. Now the answer is a fourth one. If hexadentate ligand is present, means coordination number how much, my dear students? One EDTA molecule is present in a complex compound. Its coordination number is 6. Okay. Now let's see that third one. En. En is nothing but ethylene diamine. Ethylene diamine is bidentate ligand. Is bidentate neutral ligand. Okay, is neutral ligand only because its oxidation number is 0. NH2 bond NH2. Okay, students. So here 2 donor atoms are present. 2 donor atoms. So 2 donor atoms are present means it belongs to bidentate ligand. So the answer is the second option. Okay. Let's see that. Fourth question. IUPAC nomenclature of complex compounds K2 PTCl6. Okay, now it will be ionized. 2 gives 2K plus PTCl6 2 minus. On the coordination sphere, negative charge is present means it is a negative complex compound. Okay, students, negative complex compounds. Based on the charge, complex compounds are three types: neutral and positive and negative. So negative complex compound. So the negative complex compounds are present. Then the metal name end with metal name and with ATE. That additionally we have to add ATE. Okay, while IUPAC nomenclature of complex compound, cation sphere name first. Cation sphere plus coordination sphere. In the coordination sphere, first ligands names we have to write. Ligands plus central metal. Okay, central metal plus in brackets oxidation state. Okay, then anionic sphere. Anionic sphere name, right? Here anionic sphere is not present, just cation sphere is present and ligands are chlorine, negative ligands are present, then we have to end with O, chloro. Okay, so potassium, its name is potassium hexachloro, hexachloro. What is the oxidation number of central metal atom, dear students? Here potassium is +1, here 2 are present and +2. Each chlorine oxidation state is -1, then -6 is present, sum is equal to 0, then it becomes +4. So total +2 -4, okay, plus, sorry, and this is yes, this is a +2 total, it is -6, then it is a +4. Now its name is potassium hexachloroplatinate. Potassium hexachloroplatinate. Platinate 4. Platinate 4. Potassium hexachloroplatinate, ATE. Why ATE came, dear students? It is negative complex. The negative complexes are present, then and we have to metal name and with ATE we need to write. If it is positive and neutral complexes are present, the complex compound name is as it is, central metal atom name is as it is. For example, platinum is present, platinum, copper is present, copper, gold is present, gold. Like otherwise ends with ATE we need to add. Copper is present, then cuprate. Okay, so like ATE and name will comes is very important rule. Let's see that fifth question. Let's see the fifth question. The fifth question is this is also IUPAC nomenclature only. PT NH3 thrice bromine nitrate and Cl. The outside one chlorine is present means this is anionic sphere. Anionic sphere. Okay, first we will calculate the central metal atom oxidation number. Platinum, let it be X. 3 ammonia ligands are present, the neutral ligands. Its oxidation number is 0. And 1 bromine is present, oxidation number is -1. 1 nitrate ion is present, oxidation number is -1. Here 1 chlorine atom is present in the coordination sphere, 1 chlorine atom is present in the anionic sphere. So the resultant complex is a positive complex compound. Positive complex, because on the coordination sphere positive charge is present. Okay students, now 2 into -1 is equal to 0, then the x is equal to +4. So the oxidation state of platinum is +4. Okay students, it is a +4. Now different ligands are present in that. While writing the name of the ligand, we have to follow the alphabetical order. Triamine, so this let's starts with A, this starts with B, and this starts with N, and this letter starts with C, chloro. That's according to alphabetical order. Amino will comes first, means triamino. triamino, bromo, chloro. Okay, triamino, bromo, chloro, nitro, platinum. Because it is the positive complex compound, platinum name is same, platinum only, not platinate. Platinum 4 anionic sphere name, anionic sphere 1 chlorine is present, or 1 chlorine or 2 chlorine, whatever it may be present, and the anionic sphere just simply we have to write as chloride. So the answer is triamine, bromo, chloro, nitro, platinum, 4 chloride. So third option is correct. Okay, students. Now, the name they gave, we have to draw the correct structure of the complex compound tetraamine. Tetraamine means 4 NH3 ligands present in coordination sphere. Okay, students. Tetraamine diaqua. Diaqua means 2 water molecules are present in the coordination sphere. Okay, and copper. Copper is a central metal with oxidation state is equal to +2. And hydroxide. Hydroxide means OH minus ions, or OH minus or OH is present in anionic sphere. Anionic sphere. Now, tetraamine, copper is the central metal ion. Copper is bonded with tetra means 4. Tetra, 4 ammonia ligands, and diaqua, 2 water molecules are present. How many hydroxide ions are present? Because this oxidation number is 0, so water oxidation number is also 0. But the central metal atom oxidation number is equal to +2. When +2 will come, dear students, the hydroxide ions 2 are present. Because each oxidation number is -1, then the total is equal to -2. So it is -2, it is +2. That's why the correct representation is CuNH3 4 times, H2O twice, square brackets, OH twice. OH twice. That is the correct representation. Let's see that like representation where it is present. See this third option, CuNH3 4 times, H2O, OH twice. Third option is correct. Okay, students. This third option is correct. Let's see that next question. Seventh question related to isomerism concept. Like complex compounds in organic chemistry, we are discussed that isomerism clearly, structural isomerism and stereoisomerism. The same way, the complex compounds also having structural isomerism as well as stereoisomerism is also present. Stereoisomerism means here geometrical isomerism and optical isomerism also possible for complex compounds with coordination number coordination number 4 and coordination number 6. Okay, students, let's listen. Now we'll discuss that. Seventh, the complexes CONH3 6 times and C2O4. If you are observed this, both pairs NH3 ligands are exchanged between the coordination spheres. This chromium is bonded with oxalate. Now here ammonia is present, and cobalt is bonded with ammonia. Oxalate ion is present. So in which ligands are exchanged? Ligands are exchanged between two coordination spheres. Coordination spheres, and they having same molecular formula. So isomerism concept means first we have to check molecular formula is same or not. After that, what type of changes are present? According to that changes, then we can observe that what type of isomerism. Then it is called as coordination isomers. Coordination isomerism or coordination isomers. Okay, and the phenomenon is known as a coordination isomerism. So the answer is the third option. Let's see the eighth question, dear students. Eighth question, which of the following complex will show geometrical isomerism? PT, platinum, NH3 twice Cl2 is a square planar complex. Square planar complex like Ma2B2 plus or minus n. So it shows geometrical isomerism. It has two geometrical isomers are present. Geometrical isomers are present, cis and trans. Okay, students, the same kind of questions are repeating in board examination also. They will give one complex formula. They will ask, write the geometrical isomers or draw the correct geometrical isomers. How to write the cis and trans, dear students? Platinum is the central atom. Around the platinum, same groups are in the same side. Then it is called cis. If they are in opposite side, it is called as a trans. It is a cis because the chlorine atoms are on the same side. If it is a trans, means just to exchange the ligands from right to left and left to right, then we'll get platinum, chlorine, and chlorine will be opposite came, and NH3 and NH3 opposite came. Now it is a trans. So that's why this is, but remaining, let's see the remaining second option. So the answer is first option. Let's see the second option. Platinum is the central atom MaB5. MaB5 means coordination number 6. But Ma5b does not show geometrical isomerism. Third option also MA5B, whatever it may be, MAB5 or MA5B is similar, only that does not show geometrical isomerism. And the fourth one is MA6. All 6 ligands are same. Six ligands are same means it does not show geometrical isomerism. Okay, students. So the answer is first option is correct. Next, let's see ninth question, important. They gave one complex which exhibits what type of isomerism they are asked. Okay, this kind of questions also important for objective exams. Let's see ninth question. CONH3 thrice and H2O thrice Cl3 shows is just like Ma3B3 plus or minus n, shows geometrical isomerism. Okay, students, but it does not show any ionization isomerism. Structural isomerism are not possible. Structural isomers means linkage isomerism. No, it does not show any linkage isomerism because it doesn't contain any ambidendant ligands. It does not show any ionization isomerism. In order to show ionization isomerism means the anionic sphere contain negative ligands, and coordination sphere also contains negative ligands are required. This is neutral, and water is also neutral ligands. So it does not show any. It does not show any hydrated ionization isomerism, and it does not show any hydrated isomerism also. So here hydrated isomerism, but it shows hydrated isomerism. It shows hydrated isomerism. Hydrated isomerism means what? Water molecules are exchanged from coordination sphere to anionic sphere. means it will be like this: CO NH3 thrice, Cl H2O twice, like one Cl2 H2O, like 1 water molecule will be exchanged. CO NH3 thrice, Cl2 H2O, Cl2H2O, like another one water molecule also will be exchanged. NH3 Cl3 3H2O. So these are hydrated isomers. But hydrated isomerism option is not present. Linkage isomerism is not possible. Ionization is not possible. And coordination isomerism is not possible. It shows geometrical isomerism as well as hydrated isomerism. Okay, students. What are the two geometrical isomers? Let's see. Metal cobalt is the central atom. Its coordination number is 6. Now the same three NH3 ligands are on the same side, then it is called cis or facial, and the remaining water molecules on the same side. Okay, then H2O, and one water molecule will be exchanged. Then it is merido or trans. This is facial or cis. The remaining NH3 and NH3. This water and water will be opposite came. Like the remaining three NH3s are in opposite. Like it is a trans or a merido. Cis or facial. Ma3B3 exhibits a geometrical isomerism. Okay, one cis and one trans isomers are present. So the answer is first option. Let's see the 10th question, dear students. Now let's see here. CO NH3 4 times, NO2 twice, Cl. It is a negative ligand, negative and ambidextrant ligand. So it exhibits linkage and ionization isomerism. Linkage and ionization isomerism. Okay, that is very important. And this complex seems to be Ma4B2 type of complex. It exhibits geometrical isomerism. It exhibits a geometrical isomerism. So the answer is linkage, ionization, and geometrical isomerism. First option is correct. Let's see the given geometrical isomers. CO is the central atom, cobalt, and 4 NH3 ligands are in the one side and 2 chlorine ligands are on the one side. Then it is called cis. If that chlorine are in the opposite side came, then it is called trans. So these are the cis and trans arrangements of Ma4B2. So that's why Ma4B2 is the general representation of the complex. Whatever it may be, M is central metal atom, 4 similar monodentate ligands and 2 monodentate ligands are similar, then it exhibits geometrical isomerism. Okay, students. So instead of along with this geometrical isomerism, this given complex also possible for linkage as well as ionization isomerisms. So the answer is first one. Why it is able to show linkage isomerism, dear students? NO is ambidextrant ligand. So for this it is 1. And if you are observed this, I will write one more structural arrangement for linkage isomerism. CONH3 4 times ONO twice. Here that donor atom is oxygen, here donor atom is nitrogen, and Cl2. So 1 and 2 are linkage. Next, one more structural representation. Let's see regarding ionization isomerism. CONH3 4 times NO2 Cl and NO2. The NO2 is negative ligand and Cl also negative ligand. So the ligands are exchanged from coordination sphere to anionic sphere and anionic sphere to coordination sphere. That's why 1 and 3 are ionization isomers. Ionization isomers. Okay, students. Now I think you understood that. So the given complex CONH3 4 times NO2 twice Cl exhibits geometrical isomerism, linkage, and ionization isomerism. So we have to identify very easily whether that given complex exhibits ionization or not, hydrated isomerism or not, linkage isomerism or not, coordination isomerism or not, coordinations isomerism or not. These are the 4 different types of structural isomers. Another stereo isomers are geometrical isomers and optical isomers, optical isomerism. Okay, students. Let's see that 11th question. Yes. So the 11th question, what we want, dear students, we have to identify which of the following is an example for coordination isomerism. Just now only we are discussed. Coordination isomerism. Coordination isomerism means the ligands are exchanged. So already the second or third question we are discussed. Ligands are exchanged between two coordination spheres. Two coordination spheres with the same molecular formula. Let's see the first one. If you observe that the first one, the Br minus and SO4 2 minus will be exchanged from coordination sphere to anionic sphere. That's why these are called ionization isomers. The second one is here a nitrogen donor. Here the oxygen donor. That's why the second option is linkage isomers. Okay, now here let's see that water molecules are exchanged between the coordination sphere to anionic sphere. That's why this is hydrated isomerism. Hydrated isomerism. Okay, students. Now the fourth one is if you observe that NH3 and CN, the ligands are exchanged between the two coordination sphere, then the resultant complex both relation is a coordination isomerism or coordination isomers. Okay, so the answer is what we have to check. We have to check whether the given 4 options, which option has a coordination isomers. So that is answer 4th one. Along that, the remaining also I explained what type of isomerism is possible for remaining. Okay, students. Let's see that 12th question. These all are very, very important, dear students. VBT theory and CFT theory, crystal field splitting theory. Now, the 12th question, this kind of questions are very, very important. Compulsory one question guarantee for JEE and NEET also. Fe, F6, 3 plus. See here, fluoride ions are mono-negative ligands. Mono-negative. That's why iron oxidation number is X plus 6 into minus 1 is equal to plus 3. Then X is equal to plus 3. Okay, now we got iron plus 3 oxidation state. Now we have to find out its hybridization and number of unpaired electrons. So the hybridization and number of unpaired electrons is depends on the nature of ligand. Fluoride ions are weak field ligands. Then the d electrons d electrons pairing takes place according to pairing takes place according to Hund's rule. According to Hund's rule. So iron in plus 3 oxidation state. Iron plus 3. Iron plus 3 Z. Iron Z is equal to 26 means 3s2 sorry 3d6 4s2 argon. Iron Z is equal to 26. Its electronic configuration is argon 3d6 4s2. But iron plus 3 means 3 electrons we have to remove. Then it is argon 3d5. d5 electrons, 5 electrons present in d orbitals. That pairing are filled according to Hund's rule. According to Hund's rule means what it is, dear students? So 3d means 3d cell has 5 d orbitals are present. So that electrons are filled according to Hund's rule means 5 electrons and 5 degenerate orbitals are present. Each orbital is takes with 1 electrons. So 3d5. Then outer 4s0, 4p0 and 4d0. Then the outer shell electrons are involving in hybridization. 5. Out of that, 1 s orbital and 3 orbitals and 2 d orbitals involving in hybridization forms sp3d2 hybridization with coordination number 6. Here the coordination number is equal to 6. Okay. Now number of unpaired electrons n is equals to 5. Number of unpaired electrons are 5 and hybridization is sp3d2 means outer sphere complex. Outer sphere complex. Outer sphere complex. These are also known as high spin complex. High spin complex. So like different names are present. Okay. Now the answer is sp3d25. Okay, students. This kind of questions we are discussed in board examination also is very important for board exam also. Let's see the 13th question. How many EDTA molecules are required for make octahedral complex? Octahedral complex. Octahedral complex means coordination number is equal to 6. Okay, EDTA is EDT already before only we are explained discuss the structure of EDT. EDTA has a hexadentate ligand. Hexadentate ligand means one EDTA molecule is required. So it's hexadentate means 6 donor atoms are present. To form octahedral complex, how many EDTA molecules are required? 1 is enough. Okay, one EDTA molecule is enough to formation of octahedral complex with calcium plus 2 ions. Okay, let's see that 14th question. Which of the following complex will exhibits the minimum paramagnetic nature? Minimum means less number of unpaired electrons. 14th question, minimum paramagnetic. Minimum paramagnetic means less number of unpaired electrons. That is less number of unpaired electrons. Okay, now if you observe that the given 4 complex compounds has water H2O ligands are present. Water is a weak field ligand. So that d electrons filled according to Hund's rule. According to Hund's rule. Okay, students. Now the first one is iron plus 2. Water is a weak field ligand and neutral. neutral. So its oxidation state of water is 0. Now iron, what is the charge on this complex? +2. That's why iron is present in +2 state. Iron +2 means 3d6. 3d6 means already that electrons are filled according to Hund's rule, means n is equal to 4. Next, Mn+2. Mn+2 means 3d5. Then n is equal to 5. Third option, let's see, CrH2O 6 times 3 plus means chromium is present in +3 state. Chromium electronic configuration is argon 3d5 4s1. So total 6 electrons are there. Out of 6, 1 is removed. Sorry, 3 are removed, means d3. 3d3. Then n is equal to 3. Next, nickel NiH2O 6 times +2. Nickel in +2 state means 3d8. That 8 electrons are filled according to Hund's rule, means n is equal to 2. Number of unpaired electrons 2. So the nickel NiH2O 6 times 2 plus has a less number of unpaired electrons. That's why it has minimum paramagnetic nature. Okay. So the answer is fourth option. Okay, students. Let's see that 15th question. 15th question very easy. FeCN 6 4 minus means iron present in +2 oxidation state. Cn is a strong field mono-negative ligand. Mono-negative ligand. Its oxidation state is equal to -1. Cn minus. Next, F minus. F minus means Fe F6. Fe F6 3 minus. So